This tutorial will demonstrate how to install these 8 essential technologies as indicated on the screen on a fresh installation of Windows. So the first thing I'll do is to customize my background page for that personal experience. After having done that, I'm going to go and open a command line, and then I'm going to try and run a Linux command pwd, which obviously won't work because it's not a Linux machine. So in this case I'm going to install git bash. Okay, so if in case you don't know, you could just take any browser of your choice. In this case I'm using Google. Then go to git bash homepage, and in my case I'm downloading git bash for Windows. And then once you have that downloaded, just go ahead and install it. So all you got to do then is click through all the processes, go next until you've reached the final installation page. Now you'll notice that if I try to do the same thing again, it still won't work because we need to link the environment variables in our system to where git bash is. So in that case I'm just going to open the file explorer in Windows, and I'm going to navigate to where git bash is installed. So I'm looking for the gitbash.exe file under my local drive. Now we're looking for the Linux bash terminal, which is almost always under the same folder under users, under bin. Make sure to copy the path up to the bin folder, then open an environment variables dialog box and navigate to path under system variables and paste the directory there. Then just click OK. You'll notice it still doesn't work. We just have to open a new command line and try it. So this is the directory up to my current folder. Next up, we're going to install Python. But before we do, let's just check the version by typing python ---- version. Okay, so as you can see, we don't yet have it installed, so we're going to have to visit the web once again. Okay, then go to Python downloads. Okay, and once you get to the home page, just navigate to the Windows installer. The reason why we need Python is to install the Jupyter notebooks using the Python installer packages pip. And it makes the process a lot easier. So once you click the installer, make sure to add the Python path to environment variables, which basically does the same thing we've done with git bash previously, but basically automates that process for us. So now just wait for the setup to complete. Now let's confirm the Python installation by typing the same command as before, python ---- version. Okay, and as you can see, Python has been successfully installed. So now we're ready to install the Jupyter Lab environment by running the command pip install Jupyter Lab. So next, I'm just going to clear this screen, and then I'm going to launch Jupyter Lab. Okay, so that is the incorrect command. Let's try again. Okay, so there should be a space between Jupyter and Lab. And as you can see, a server is about to start up. Just pick the browser of your choice as default. Okay, if you make that full screen, you'll see that Jupyter is successfully loaded up. And let's create a Python notebook. That's an ipynb file. Okay, so I'm just going to print hello world to the screen. You know, this is not really a coding tutorial or any of that. It's just a environment setup. I'm just gonna rename this folder to hello world, whatever. So next we're just going to install Jupyter Notebooks as well, which is basically just like a lightweight environment for Jupyter Lab. It's pretty much the same thing, it's just a couple of extra features that Jupyter Lab has. Notebook is more like for quick documents that you would like to quickly type up, do some quick projects, etc. So once again, just wait for the download to complete. So now that we've completely installed Notebooks, let's quickly launch just to see that it has been correctly configured. We see a /tree directory in our localhost server pop up. And so now I can navigate to where I've previously dropped the Hello World folder just to test this out here. And as you can see, still the same thing, although you should probably compile it to make sure that it's actually functioning as expected. So next, I'm just gonna look for a dark mode to Jupyter Notebooks, because I don't like this brightness on my eyes. It's a bit uncomfortable to work on for long periods of time. So after having tried about everything, we land on this page on the support of Jupyter Dark Mode, which says that it does not function with the new Jupyter Notebooks, since I'm using the latest installation. So we're gonna have to find a different way of doing this. So thankfully, the latest release of Jupyter Lab has included a dark mode. Let's see if that's also the case for Jupyter Notebooks. Oh, this is great news. Next up, we're gonna install the C# compiler. But as you can see, I don't currently have it on my system. So there is one or two ways that we can do this. Either we can install the compiler directly, or we can just install the .NET framework using the Visual Studio installer tool, which is what I'll be doing. So I'm just launching this installer, and once that comes on, I'll just click continue. So this launched the installer page, and this is where you have to select the technologies that you would be making most use of. I would just like to keep my environment lightweight at this point, so perhaps I'm just checking too many boxes at this point, but just to show you all the options that are available. We have C++ developing for desktop applications, as well as mobile applications. We have Unity for game development. We have cloud computing, options over here. But I'm just gonna stick with like the bare minimum and install really what's needed, because you could always come back to this page, the installer page for the Visual Studio .NET framework, and just update what technologies you would like to include later on in this in your journey for computing and whatever. So yeah, I think this is what I would like. I'm just gonna stick with these three for now. Let me also just remove that ASP.NET, and yeah, I think I'm satisfied. So then you just go ahead and download everything, or you can install and download simultaneously if your internet is stable enough. But for me, I'm not like that confident in my ISP, so I'll just stick with downloading beforehand and then installing it. So there you go. So this is going to be quite a long process. I would suggest you maybe take a cup of coffee or something, although I will just speed up the video on your side, though. Can't really fast forward any of the real world. So in that case, just sit back, relax, and wait for the installer to do its task. Yeah. So if you're anything like me, you would probably want the CSC compiler to be accessible via the command line. But as you can see, currently it's not, so we're gonna follow a similar process as before with git bash, by locating where the CSC compiler is in our local disk. And that's almost always again under the same folder, except depending on the version of .NET that you're using. And so once you've located that, once again just copy the folder path up to where the CSC compiler is, that .exe file, and then go to the environment variables on your PC, and then edit the path environment variables on your system and paste that directory path in there. Okay, and so just click OK to save that, and once that's done, let's just test it by running CSC, and as you can see, it does recognize the compiler path. So now let's quickly create a test project just to test the compiler and that everything relating to C# is working correctly. I'm just creating a .cs file. I'm just going to open that with Notepad, and I'm going to just type some C# instructions to the machine over here. That's namespace. Just gonna create a class inside this namespace, which I'm gonna call class, test class, and then I'm just gonna create a main entry point to the program, public static void main, and inside there just include the argument string, and then just gonna write something to the console, like print hello world, whatever. Okay, so that's system.console.writeLine. Just be sure of the capitalization over here, and then I'm just gonna create a read key instruction as well, so that when we launch this in the command line, it does not close, just so that we can see the result there in the command line to make sure everything's working as expected. Okay, so let's go ahead and open this in the terminal, and then navigate to the directory in which this file lives. That's cd desktop. Okay, so once I'm in my desktop, I'm just going to run csc test.cs, and that's going to create this .exe file, which I can easily run. So next we're just going to check if .NET has been installed by running .NET version, so that we can also install the .NET interactive notebooks, which will allow us to write C# code in a Jupyter Notebook environment. Okay, so we're just going to navigate to the NuGet package for the .NET interactive tools by visiting this website link over here. Okay, that's the one. So we can just take this command line argument here, and I'm just going to use a slightly different version of that. I'm going to use -G for global, which will allow me to use .NET anywhere on my PC. Next, we're just going to install the .NET interactive tools, which will set us up for installing the notebook environment. Okay, so that command is .NET tool install -G for global Microsoft.NET interactive. So just have to be patient and wait for this process to complete. Now we can just run the command .NET interactive Jupyter install, which will just install the Jupyter kernel associated with the .NET framework for us to write C# code in Jupyter Labs. We're now ready to go and test this by running a Jupyter notebook server, which will obviously open a new browser window for us. So I'm just gonna create a new notebook file, and upon launching that, you can see that we have provided the option of choosing a kernel, in this case C#, and I'll just write console write line in that cell, and then maybe something like hello world, just for testing, and then I'm gonna just use shift enter to get the result, just to show that it's actually working. Next, we're going to create the same setup for a Java environment. But first, let's check the version of Java. This has been provided by the .NET framework. And currently I'm just checking where the compiler, the Java compiler, is located. You might want to install the latest Java development kit for your system, but for presentation purposes I think this will just do. So I'm just going to navigate in the file explorer inside of my local disk to where that Java compiler is located. If you do decide to install the latest version of the JDK, you will have to set the path to the Java compiler in your environment variables, as we have done before with Git, Bash, as well as the CSC compiler. So let's just create a new test.java file to test whether Java has been configured correctly, inside of which I will just type some system instructions over here, a class called test. Inside I will create a public static void main method as an entry point for my program, passing in string arguments. And I will just system out print line something to the console. Next we'll open a command line and navigate to the desktop, and then we will compile this test.java file, which will create this .class file, which we will then run from the command line just using Java test, and that just outputs to the console hello world, so that works fine. Next we want to set up a notebook environment, so we're going to navigate to iJava Spencer Park's GitHub page, and over here we will go down to releases on the right hand side, click on that link, and then go all the way down to assets, under which I'll just pick the first link. That'll download the iJava kernel for us. Just save that anywhere on your machine, and after downloading that, we will just have to extract this folder. I'll just delete the zipped file for now. And then I'm going to take these two extracted files and move them to my C drive under program files, under the Java folder that I will create, where I will place all related Java related folders and files. In fact, let me just also place these in an iJava file, because there may be more Java files to come, just to keep everything neat and organized. Okay, so once we've done that, all you really got to do is run the Python installer. Now you have a Jupyter environment for Java. Let's test. So just run Jupyter notebooks in a command line, and this will open a server. And once this is opened, we can now create a new notebook file. Let me just get rid of that one. Let's create a new notebook file, and again it will prompt us what kernel we would like to use, and we can see from the list we have a Java option. So now we're just going to write some simple Java code, system.out.println, and again it's going to just be a hello world output, just to test whether this iJava kernel has been configured. Next, we're just going to take all the Java related files and folders, such as the JUnit test framework, etc., and also JavaFX. I'm gonna just place all of that under the related Java folder in the program files. Okay, so cool, that's done. Let's try and extract this. Seems like that didn't work. So I'm just gonna dump it on my desktop and extract it there instead. And then I'm gonna just move it back. Okay, cool. So now we want to do the same setup for C and C++. So to do that, let's first check whether we have the C compiler and the C++ compiler. So it seems we don't have GCC installed, and for that, of course, we go to the web again. In this case, there's many places that you could find the C compiler. I'm just gonna go to WinLibs, and then over here I'm gonna download the POSIX version of the compiler. So you'll see just down where it says release versions, I'll just pick the appropriate one over there. Okay, and then I'll just save it to my programs folder. But the fact is that I've already got it downloaded, so I'll just demonstrate from there onwards. So to install GCC is quite simple. We're just going to extract this folder and its contents. once extracted, I'm just gonna move it to my local drive, and I'm just gonna place it inside of the program files. So all we gotta do now is to locate the bin folder and copy the directory up to the bin folder and paste this in the environment variables as we've done before, but with the git bash and C# compiler. I'm just gonna go to edit path variables in the systems variables and create a new path in there. Just click OK to save. So let's just test that. So I'm going to open a command line and run gcc. In fact, I'm just going to run gcc -- version, so to check whether that file has been recognized, its file path is correctly set. I'm just going to create a .c file using Notepad. Okay, so let me rename that. And inside I'm just going to create some simple C code. Once again, just a hello world sort of console output to check whether the C compiler actually functions correctly. So I'm just going to include the standard input output header file and then write some method, main method returning integer, and then I'm going to just say printf hello world, and I'm just going to return 0. Okay, so don't worry if you don't understand C at this point, or C++. We'll do a tutorial in the future of these languages, and there's a lot more to be said, but for now we're just trying to set up our environment. Next, I'm just going to test the compilation process for the GCC compiler. So that's gcc test. In fact, I forgot the flags -o, and I should also include a name for the output file. So I just want to call my file test. That's going to produce a file called test.exe. I'm swapping the order here by mistake, so that should actually be test C, and the argument before that should just be test. So let me just head up and fix that. Okay, cool. So now you'll see that output. And now I want to run that in the console, so I'm going to write test.exe. It's going to say hello world. There we go. Alright, so that works fine. We're going to do the same thing for G++, which is basically the compiler for C++. And the cool thing is here I don't really have to change much, only the file name to CPP, and then we'll use the G++ compiler, although you could still use the GCC compiler for C++ as well. It really does not make any difference. Okay, cool, so that works. I'm going to run that in the terminal by typing test.exe, which will produce again a hello world. There we go. So everything's as expected, and we can move on to the next phase. Next, we're going to set up the Jupyter Notebook environment for C++, and to do that we have to look at the documentation at Zeus Kling's GitHub page. But unfortunately you will notice that they do not support the Windows platform at this point, because I guess it's still in the development process. However, there is a workaround. At this link, some person wrote this blog at NVN, and in it he demonstrates how to install the Zeus Kling environment in a Windows subsystem for Linux, which is great. So the really cool thing about WSL is that it's not a virtual environment. It's basically accessible via your your Windows system as well, and vice versa. So we can basically like pass around files between the two different operating systems. To install a subsystem, I'm just going to run the command WSL-install, and it's by default it's going to be installing the Ubuntu distribution of Linux. And so, once again, you can just be patient about this process and wait for it to complete. Once that's done, just go ahead and create a username and a password. So now we have an Ubuntu subsystem installed on our Windows machine. So let's just go through some of the features here a little bit. Okay, so first thing I'm going to do is just print working directory and then see where that's pointing to. So to access the Ubuntu system, I'm just going to type // and then WSL $, and then that's going to take me to the subsystem, in which you'll see a home folder, and then inside there your username. From Windows point of view, you're going to find that under local disk, users, app data, local, and then just gonna navigate here quick. Canonical. Okay, so this directory here is basically where the Ubuntu subsystem has been installed. So for this to function properly, all we're going to do now is just to restart the PC. Okay, so once I've gotten into an Ubuntu console over here, I'm just going to run some updates. So that's sudo apt-get update, and then you have to just obviously enter your password.
Ja, is baar geluk om ook Jim dragen te Slama. Juma Slama.
now I just want to make sure that I have wget installed. So apt-get install wget. Okay, so that's already installed. So now we will just install mini-conda. Obviously first we will download that using wget, which will then fetch the data from the repo. Once that has been downloaded, we want to extract that on our Linux subsystem using bash. Then to install that, you just have to hit enter and then hit spacebar a couple of times until you get to the prompt where you can then type yes, and then again, once that's completed, you want to just type yes again and hit enter. So now what we gotta do is to update Anaconda by using this command. Okay, so before we do that, we have to probably initialize Anaconda. Okay, so obviously that also didn't work. We have to first set the source to bash rc.sh. So let's just find that folder in the Linux subsystem file directories. Just gonna search through that quick. So this is a nice feature about the Linux subsystem for Windows, is that we can pretty much use the file explorer to inspect our Linux files. So okay, inside the conda folder there's this file called bashrc. I just want to make sure that we're in the right directory. So that bashrc file is the one that we want to set to the source. So what we gotta do here is just type source tilde /.bash rc. So that's gonna initialize the base for the environment, and then we're gonna just perform the previous again, conda init, initialize, and conda update conda. So now we'll just create a new C++ environment in which we will contain all our configuration files and our notebook package, etc., as well as this use cling package that we're going to be downloading and installing in there. Okay, so once that's done, we just want to activate the CPP environment. Now we're just going to use conda to install Jupyter notebooks. Once that's completed, we're just going to install use cling using conda forge. Next we're just going to install the Jupyter Notebook extensions, which is going to allow us to change and adjust some of the configuration settings for Jupyter Notebook and Jupyter Labs, such as, for example, to specify the browser which to open once the server is running. Now we just want to install the Notebook Extensions configurator, which is what will allow us to actually change some of the configuration settings. So as you can see, this has already been installed upon installing the Notebook extensions. Next, we just want to configure the Jupyter Notebook environment to allow the user of this subsystem to be able to make changes. So I just want to navigate to the .jupyter folder, so that once we do adjust some of the configuration settings and produce a configuration file, that we can see the changes happening in real time. I'm also just going to make a new directory called C++ notebooks, in which I will store the notebooks that are launched from inside this server. So now we're just going to produce a configuration file for Jupyter Notebook, in which we can then specify our configuration settings. And once you run this command, you should see it appear in this file explorer over here. I have a typo. You should just remove that R over there to say generate config. So So running that again, you might have to refresh the File Explorer, open that Python file in the notepad, and look for the line called redirect, use redirect file with underscores, and notice that it says equals to true, and it's also commented out with the hash symbol in front. And what we want to do is just to set that equals to false. Well, you could actually physically type that out, but currently I'm just typing in the console over here. C notebook app dot use underscore redirect underscore file equals false, and then I'm pointing to the file to which I want to write this information, and we'll just reproduce that at the bottom of that notepad file. So let me just run this command, and might have to close the notepad file and open it again to see the changes take effect. So now I just want to set the default browser for the Ubuntu system by using this export browser in capitals equals, and then point to mount, which is the drive on which this installation is, and then the C drive, that's basically pointing to my Windows machine, and then the rest of the line it's pointing towards where Google the exe file is contained, so that once we do open anything in the browser, it'll always point to our Google application inside of Windows. So by running that, it just stores it to memory for this session. So over here, I'm just showing you the directory to which the browser export is pointing to in the Linux subsystem. So let's try and run Jupyter Notebook and see what's happening. So currently the kernel is starting up, but we're not actually getting the correct. It's not pointing to the correct launch page. So we're gonna have to troubleshoot a little bit and go through some of the previous commands that we ran on the Linux terminal over here. So I've just made this little typo where I've typed an A instead of an E, so let's just go in on that line. I'll just navigate all the way back using the back key all the way to that A, just replace that with E, and just rerun that, and now start up the Jupyter kernel again. So over here you can see the folder called C++, and I'm just going to create a new C++ 14 notebook file here, and just going to type some simple C++ commands just to test whether it's working correctly or not. So at this point we only have the Jupyter notebooks installed, so we can't really, change it to dark mode or anything like that. So for that, we're going to probably need to install Jupyter Lab, so that will be our next step over here. So once that has been downloaded and installed, let's actually launch Jupyter Lab to see what it looks like and whether or not we can change it to dark mode. Just navigating to settings, themes, dark mode. So let's just create a quick test project just to make sure that Jupyter Lab is also configured and is running correctly. So our next step is to create a shortcut link that will launch the Jupyter kernel inside of the Ubuntu subsystem each and every time that we click on it, because as you can see from the following demonstration that I'm doing over here, the browser variable of the previous shell session is only stored as long as the session is running, and so we no longer have access to that preferred or default browser that we've set. So to fix this, we're just gonna create a shortcut file, like a bash file inside of Ubuntu, and inside of that file we'll write some commands that will always be run once we click on the shortcut link. So I'm just going to navigate to the users directory, which is just cd tilde, and then I'm just going to create a nano file. I'm going to use the nano text editor to create a file called shortcut.sh. So that's a shell script file, and inside obviously we're going to use the shebang followed by the header bin bash. And then what I would like to do is every time this file is opened, it should just change the directory to the C++ notebooks directory. So right after this, we just want to set the mini conda's active environment so that it knows where to find that. So we're going to just point it to the source so that we can then activate the C++ environment that we've created earlier. So right now I'm just navigating to to the folder which contains this conda.sh file inside of the Linux subsystem that I want you to see. Just take note that this the shortcut.sh file that we're currently working in, we won't actually run that in the terminal. You know, for this session, we will actually just that file will be launched every time that we click on the shortcut that we will still create on our Windows desktop in just a bit. So I've just activated the C++ environment for conda, and then we're just going to export the browser. We're going to set like a variable inside of the Windows subsystem for the default browser using this export command. So that's basically like a environment variable in Linux. And then I just want to echo the environment variable to the Linux terminal every time that this file gets launched. And then I want to call the Jupyter Lab kernel and start that up so that the server gets, you know, launched. So to save this file, I'm just going to hit Control O, and then to exit, Control X. I'm just going to go back and check if this information is still the same, and then hit Control X again. I'm just going to clear the terminal. So now we can actually create the shortcut file. Go new, and then to shortcut, and inside of here we're just going to type the long command. First it's going to point to the C drive in Windows, and then to system 32, and then to the WSL.exe. So that's the Windows subsystem for Linux. So I want to execute this bash command, which I'm currently typing in here. And to do that, yeah, I have to open up these quotation marks and type inside of there what's supposed to happen in the Linux system. So I'm gonna invoke a bash inside of Linux, and then call the script shortcut.sh. Okay, so save that. We can create a new name for it. I'm just gonna call it C++ Jupyter kernel. So now we can just test this by double clicking it, and as you can see, it's giving us back the environment variable for the default browser, and it actually launches the server. Let's just see if it takes us to the Jupyter Lab, which it does. And now I can actually choose from the kernels, or I can just create a new file that I wish. But I have C++ and Python to my disposal here. I can create any type of project that I want on this system within the Jupyter Notebook environment. So that's fancy as hell. I think it's very important to mention just that the shell script that we've created cannot be created inside of the Windows File Explorer using Notebook, because it will not work. You have to create that using within this Linux terminal. Okay, so over here I'm just quickly going to create a main method to test the C++ environment that we've just set up to see if everything functions correctly. So I'm just going to create a printf statement and return 0. Inside of the print statement, I'm just going to write hello world to the console, and let's see what we get. So when I invoke the main method, I should get hello world as expected. So one last thing that I would just like to do is to change the icon of my shortcut to something more relevant, like the C++ icon, so that I know what it refers to every time that I click on it. As a final touch, we're just going to install the Visual Studio Code editor. So I'm just going to head over to the extensions tab and I'm going to search for polyglot notebooks, which is pretty much like a Jupyter server in a sense, within the Visual Studio Code environment, in a sense that it has some of the exact same features with some added benefits, but it also does have some other drawbacks. For example, it doesn't support C++. Once that has completely been installed, we can just hit Ctrl-Shift-P and search for interactive notebooks. And then under that, you would like to just search the kernel that you want to create. In this case, I just chose a C# kernel, and I'm just going to write console write line and then print out hello world to the console. Now you've got the developer's environment that every developer has ever dreamed of, all within one place pretty much. So that's it for this tutorial. I hope you enjoyed it. There's quite a bit more to come.